Everyone, welcome back to another videos. Today I want to solve a problem that I made. I actually made this problem, and this problem was actually motivated by a different combinatorial problem. I think yes, and I think that problem, like the previous problem, taught me a lot. So that's why I made like my version of it. So this is how it goes. There are 999 mysterious thinking trees, each labeled uniquely from 1 to 999. So our this is our first tree. It's labeled 1. Our second tree is labeled 2. Our third one is labeled 3, and then so on. And we have 999 trees. And a boy comes and waters this one, and like waters this one, and waters this one. We don't know how many this guy waters, but like if we take the sum of everything, so if the boy watered number 2 and number 3, then we add 2 and 3. If the boy watered 3 and 999, we add 3 and 999. If the number, like the sum, is divisible by 3, then a magical seed will fall from the sky to the boy. Now, a young boy named Enoch, he heard about the legend and wanted to make his own farm. So how many seed can he receive by watering the trees? That's basically what the question is saying. And actually, to be honest, it might not be like really straightforward. So let's restate this problem. So it is asking us to find how many ways are there to choose numbers from 1 through 999 such that, so how many ways are there to choose numbers from 1 to 99 such that the sum is divisible by 3. Now this problem, it can be restated in the set 1 through 1 to and then 999. How many subsets of the set has the elements in which, wait, is my grammar correct? How many subsets of the set has the elements in which their sum is divisible by 3? So that's what the problem is saying. So we are supposed to find the number of subsets in which the sum of their elements are divisible by 3. So for example, 3 works, or like 1, 2, it also works. What do you have also, like 999, 981, this also works. Yeah. So how many subsets are there to satisfy this? So actually what we can think is there are multiple things that we can try, but usually when there are like this sequence and the sequence is quite big, then usually we think of generating functions. So that's why consider this function f of x equals 1 plus x times 1 plus x squared times up until 1 plus x to the power of 999. Now, think of it like this. So we have our exponent 1, 2, and then 999, right? these all numbers correspond to the elements in the set, and the coefficients of like x to the power of n, it refers to it completely mirrors the number of subsets in which their elements sum up to n. So yes, I know this might be confusing, so let me give quite an example. So like let's say exponent is 4. So how many are there? In this case, our coefficient will be what's our coefficient? 1. Wait. 1. No, actually, I don't think this is a great example. Let's try with 6. When our exponent is 6, we have 6, 1, 5, 2, 4, 1, 2, 3, and 6. So our coefficient will also be 6, right? Like in terms of when we expand this. Now consider the case, the subset 1, 5, 2, 4. Wait, it's 4, not 6. Because 6, 1, 5, 2, 4. Yeah, it's 4. Sorry, my bad. I miscalculated suddenly. 1, 2, 3. So these subsets add up to 6, and that represents the exponent. And how many of them are there? 4, right? And these two correspond to each other. So actually, when you take a moment to think more about the relationship between these two, then you might realize that they're completely the same thing but mirrored. Yes, so what we need to find is, like, we have something here, our coefficient for something, right? And we want to find I'll say n. We want to find the sum of all these the coefficients. That's what we want to find here. And how do we do that? Usually, in order to find the coefficients where our exponent is a multiple of a certain integer, or like whole number, then we usually think of the root of unity filter. And what we can do here is the root of unity of 3 is equal to 3 to the power of e to the power of I 0 pi over 3, e to the power of I 2 pi over 3, e to the power of I 4 pi over 3, right? Now, without loss of generality, let's say that this is equal to omega 1, this is equal to omega 2, this is equal to omega sub 3. Now, we had our f of x equals this, right? When I equals 1 through 999, 1 plus x to the power of I. This is our f of x. We defined it like this, right? Now, let's rewrite this like this way. X sub 2. What should be our last term? Our last term is actually 1 plus all the way up to 999, so that's 500 times 999. Subtract 500. Wait, 1% minus 500 equals 499,500, right? Did I make mistake? 0, 0, 0, 0, and 5. Yes, this is right. So a sub 499,500 x 499500. Now, what we want to do here is f of, that's w, f of omega sub 1 equals a sub 0 plus a sub 1 omega sub 1 to the power of 1 plus a sub 2 omega sub 1 square plus all the way until 499500 omega sub 1 to the power of 499500. And we can do the same for squared. Why am I keep writing w? This is omega. And quickly writing them, we get this. Omega 2 599,500, and our last one equals 1 omega 3 1 plus. The reason why I'm doing this is because we can cancel out all the terms. We can find the sum of coefficients for these ones that we wanted. So actually, let's add them. Let's add all of them. We get f of omega sub 1 plus f of omega sub 2 plus f of omega sub 3 equals 3a to 0. Now, what is omega sub 1 plus omega sub 2 plus omega sub 3? It's naturally 0 using Vieta's formula, right? So we cancel these out. Now, omega sub 1 squared, omega sub 2 squared, omega sub 3 squared, what it really does is, so we have our roots here. Our first root was this one, our second root is this one, our third root is this one, right? Using for our root of unity. Wait, is it right? 60, 120, yeah. So when we square them, we're just rotating this counterclockwise once. So it will anyways be the same thing but just swapped. So this disappears. Omega sub 1 to the power of 3. 3 is just 1, so we have 3 to the power of a sub 3. Plus, we cancel out everything except for the terms with the subscript that is a multiple of 3. So now what we need to find is 3 over f of omega sub 1 plus f of omega sub 2 plus f of omega sub 3. This is what we need to find. That's like, if you find this, then we get our answer by our explanation. So how do you find this? Now notice that f of x was equal to what? 1 plus x squared all the way until 1 plus x of 999. Now notice that f of omega sub 1 equals, we said our omega sub 1 is equal to 1. Therefore, it will just simply be 2 times 2 times 2 on 999 times. Now, let's consider f of omega sub 2. This is equal to 1 plus omega sub 2 times 1 plus omega sub 2 squared times 1 plus omega sub 2 cubed. And the next one should be 1 plus omega to the power of 4. But that's the same thing as this one. Next 5, same. So we will keep repeat. It will form repetition for 333 times. And that's the same case for omega sub 3. We have repetition. Omega sub 2 cubed. Wait, what am I saying? 3 squared. 1 plus omega sub 3. Yes, this is what we have. Now, we want to compute this. Now, notice that omega sub 2 squared is simply equal to omega sub 3, right? And omega sub 2 cubed is simply omega sub 1. So, therefore, f of omega sub 2 is equal to 1 plus omega sub 1 times 1 plus omega sub 2 plus 1 plus omega sub 3 all to the power of 333. Now this is the root of equals 1. Hey, minus. What am I doing? This is x minus. This thing is the root of this equation, right? So using Vieta, we know that this expression is equal to 2. We can use Vieta's formula. And therefore, f of omega sub 2 is equal to 2 to the power of 333. And notice that that will just be the same case for omega sub 3, right? We're doing the same thing all over again. So you guys can try it on your own if you guys are interested, but please note that they are the same thing. So if we substitute them here, we have 2 to the power of 999 plus 2 to the 333 plus 2 to the power of 333 all over 3. Therefore, our answer is 2 to the power of 334 plus 2 to the power of 999 all over 3. This is the total number of seeds that Enoch can have. Now, when I first made this problem, I was like, the reason why I chose to do this is because, first of all, the generating function was studying about generating function was very interesting to me, and also the root of unity filter. It's like a technique that no one teaches. I mean, I might not have learned it, but yes. So I think our first kick is restating the problem. Second kick is generating functions. And our third one is using the root of unity filter. And I think that's about it. I think this problem was a very fundamental problem. I really loved it. Thank you for watching this video, and if you enjoyed this problem and solution, please feel free to share and write anything in the comment box below. And also please note that I couldn't fact check if my solution is correct or not. I just made it and I'm sharing it with you guys. So I'm not sure if my solution is correct or not. Please tell me if I got it right or wrong. Thank you, and see you in the next video. Bye.